Hi everyone, a very good evening. Today we are going to study the question number 72, that is Pascal's law. So what are the application of Pascal's law and what kind of questions they will ask based on Pascal's law? So what are the basic things we should understand first is what is density and pressure? See, the density of any substance we represent with d or rho, that is equal to mass by volume. And relative density of any substance means the ratio of density of the substance by density of water. And pressure, so pressure is nothing but force per unit area. And density means we can measure in terms of cc, gram per cc or kg per meter cube, and 1 gram per cc nothing but centimeter cube equal to 1000 kg per meter cube, and pressure we measure in terms of Newton per meter square or Pascal. So these are the simple things you need to remember first. Then the question can be asked sometimes based on density of mixture. Like when you consider one substance of mass M1 V1 volume V1 density rho 1 mixed with another substance M2 V2 rho 2, then the density of the mixture means total mass by total volume, or else V1 rho 1 plus V2 rho 2 by V1 plus V2, or else M1 plus M2 by M1 by rho 1 plus M2 by rho 2, means depending upon the data. If they give mass volume, one formula; if mass density is another formula. But here condition comes if V1 equal to V2 implies rho mixture equal to rho 1 plus rho 2 by 2. And if V1 equal to V2, then rho mixture will become, if V1, sorry, again same condition, M1 equal to M2, masses are same, then it will become 2 rho 1 rho 2 by rho 1 plus rho 2. So based on these formulas, question can come. Now the next thing is what is Pascal's law? So in a steady fluid or incompressible fluid, just like you consider some liquid in a container. Now you consider n number of points A and B at same depth from surface. Then pressure at A must be equal to pressure at B. So pressure at all points which are located at same depth from the surface, top surface, is always same. Or pressure at any point inside the fluid distributes equally in all the directions. That is what the statement given by Pascal. Now, based on this, when you consider suppose two different points, now the same liquid you consider, now two different points are there, so this is completely liquid. Now these 2 points like A and B, and that height difference, depth difference is h, then PB is greater than PA and PB minus PA equal to H rho G. The variation in pressure with depth, as depth increases, pressure keep on increases. Now based on this thing, sometimes they can also ask questions based on hydraulic lift. Hydraulic lift is something like, see, a simple arrangement like this. See, one side there is a small area, you will apply small force, and another side large area, and it is completely filled with fluid. But both are at same level means here pressure P1 means here pressure P2, P1 should be equal to P2. Where P1 is F1 by A1, you are applying. Now the same pressure will be transmitted here so that it will apply some force F2 on area A2 so that their pressure will become F2 by A2. But F2 by F1 equal to A2 by A1, and as A2 is greater than A1, F2 is greater than F1. So you apply small force on smaller area so that you can get the larger force on larger area. Like if area is 10 times, you can develop the 10 times, 10 multiples of force. So that is what we call it as hydraulic lift principle, which we use which we use to lift the heavy weights, just like in car garage servicing centers. Now let's see few examples based on whatever formulas we have taken. Two liquids of densities having volumes mixed. Find mixture density. So when you want to solve the question, first you have three formulas and two special cases. Then you have to decide here densities and volumes given. So you have to choose the formula properly, that this is the formula you are going to use. And where V1 is 3V, V2 is V, and rho 1 is rho, and rho 2 is 3 rho. Then if you substitute, you will get the simple answer. That is V1 rho 1, 3V rho plus V 3 rho by 3V plus V. So 3 plus 3, 6V rho by 4V. That is 3 rho by 2, or else 1.5 rho. Now the pressure, find the pressure exerted below a column of water open to the atmosphere at depth. See here. Find the pressure exerted below a column of water open to the atmosphere at depth. So now there is some water, some column of water, H. Now at the top, atmospheric pressure will be there, that is P0. Now at any depth H, the pressure will become P0 plus H rho G. And atmospheric pressure is 1 atmosphere or 1.013 into 10 power 5 Pascal. So approximately you can take 10 power 5 Newton per meter square or Pascal. Now at a depth, first question they have given at a depth 10 meter. And the second question they have given at a depth 30 meter. Just substitute the values. They have given H, rho, G, everything. Now here, this is a question based on Pascal's law. What is the density of oil? See here, this is water. This is completely water. Now these 2 points when you consider, let's take like P and Q. Pressure at P equal to pressure at Q, because both are at same level inside the same liquid. Now but here pressure means this pressure P0 plus this height of the oil HO, if you consider H rho G, HO rho oil into G, that should be equal to, here pressure means here pressure is P0 plus this height is, this is water, H water, L water into G. Now this height, this slight difference is there. Actually this value should be 135. They have given LW as 135 millimeter, means 13.5 centimeter, or you can take both sides millimeter only, no problem, they get cancelled. Now H oil is 13.5 plus 12.3, so 13.5 plus 1.23, so that 14.73, this is the oil height. When you substitute, then they are asking in the question what is the density of oil. Density of water is how much? 1 gram per cc. See, always remember density of water is 1 gram per cc. Nothing but 10 power 3 kg per meter cube. So that here the formula is HO rho O equal to HW LW. All values given, so you can find the rho oil. Now two pistons of a hydraulic machine have diameter. So R1 is 20 centimeter. Sorry, R2 is 20 centimeter. R1 is 2 centimeter, because smaller one, greater one. Then F2 by F1 equal to A2 by A1. Nothing but A2 is pi R2 square pi R1 square. So R2 by R1 whole square. Where R2 is 20 by R1 is 2 whole square means 10, 100. Now find the force exerted on the larger piston when 50 kg weight is placed on the smaller piston. So now F2 they have given. F2 should be 50 kg weight, means 50 into 10. 50 G. Find the force exerted on the larger piston when 50 kg weight. So F1 you have to find. So that then you will get the F1 value. Just substitute it so that you will get the answer. But here they have given the question reverse, that instead of giving F1, they have given F2 and they are asking you to find F1. Now our last and final question. Four vessels A, B, C and D have different shapes and hold different amount of water. Which of the following is correct? See here three different points are there. So three different points. Now all are at same level. So then whatever may be the shape above it, it doesn't matter because height remains same. Height remains same because here it is open, P naught, P naught, P naught. Everywhere pressure should be P naught. And PE minus P naught should be equal to PF minus P naught should be equal to PG minus PC should be equal to PH minus P naught. So that PE equal to PF equal to PG equal to PH, because these all equal to H rho G, same liquid, same height, according to Pascal's law. This is also called hydraulic parallax. So similar questions I have given as an assignment. So please just try to understand and try to solve similar questions I have given so that you will get the idea like how to find the density of a substance or mixture, or what is Pascal's law and how to apply in solving particular question, like pressure is same at any 2 points inside a liquid which are at same level, and how to apply or how the question will be asked based on the principle of hydraulic lift. So thank you. We'll continue in the next session with the next question. Thank you.